So hello everyone, welcome back to my YouTube channel Hasta Education. So in this video I am going to discuss about the matrix method to solve a system of equations. Alright, so let's get started. So our today's topic is solving a system of equations by the help of matrix method. Okay, so let's say I have a system of equations like this. Alright, which is given by a1x plus b1y plus c1z equals to d1, a2x plus b2y plus c2z equals to d2, a3x plus b3y plus c3z equals to d3. Alright, so let's say this is my system of equations. Okay, and I want to solve this system of equations by the help of matrix method. Okay, so here is a very important point. Don't forget to write the system of equations in standard form. Okay, so this is our first task. That means we have to write the system of equations in standard form. Okay, standard form means the x terms, y terms and z terms are properly arranged. Okay, uh, sometimes what happens, these x term, y term and z terms are haphazardly written. Okay, so first of all we have to arrange them in systematically. Okay, so x term should be in this row. Okay, y terms in b should be in this row and z term should be in this column. Okay, and similarly the constant term should be in the right RHS. Okay, so sometime what happens, these x terms are written here and these z terms are written here. Okay, that means they are written haphazardly. Okay, so our first task is we have to write down them properly. Okay, that means we have to write down the system of equation in standard form. Okay, so this is our first task. Okay, then this system of equations can be written in the matrix form. Okay, like this. Okay, this given system of equation can be written, okay, in the matrix form is something like this. Okay, that is the matrix of a1x plus b1y plus c1z, a2x plus b2y plus c2z and a3x plus b3y plus c3z. That whole matrix equals to the matrix of d1, d2 and d3. Okay, now this matrix, okay, now this matrix can be written as the product of two matrices. Okay, we can write this above matrix as the product of two matrices. Okay, and the two matrices are a1 b1 c1, a2 b2 c2, a3 b3 c3 and x y z. Okay, this is nothing. Okay, so this matrix can be written as the product of two matrices. This is the first matrix and this is our second matrix. Okay, these two matrices. Okay, so now this equation will be, okay, a1 b1 c1, a2 b2 c2, a3 b3 c3 matrix multiplied by x y z matrix. Okay, equals to d1 d2 d3, because this matrix can be written as the product of two matrix. Okay, these are this matrix and this matrix. Okay, so this matrix is let's say a matrix and this matrix is, let's say, x matrix. Okay, and this is b matrix. Okay, so this is the basically coefficient matrix. Okay, this is our coefficient matrix and this is our variable matrix. Okay, and this is the constant matrix, you can say that. So these are the three matrices. Okay, so the given system of equation can be written as the, okay, ax equals to b. Okay, so this is the system of equation in matrix form. Okay, that is ax equals to b, where a is the coefficient matrix, x is the variable matrix and b is the constant terms matrix. Okay, so this is the system of equations in the matrix form. Okay, this is the matrix form of the system of equation. Okay, so now by the pre-multiplication of A inverse matrix on both sides. Okay, so let's say we pre-multiply this A inverse matrix on both sides. Okay, so it will be A inverse into Ax equals to A inverse into B. Okay, so these two matrices will cancel each other. So now it will be x equals to A inverse into B. Okay, now x will be adjoint of A upon, okay, determinant of A into B. Okay, since the inverse of a matrix is given by adjoint of that matrix upon the determinant of that matrix. Okay, so replacing A inverse by this one, we can get x equals to adjoint of A upon determinant of A into B matrix. Okay, so now two cases may arise. Okay, so there is two cases. Case number 1, the determinant of A is not equal to 0 and determinant of A equals to 0. Okay, so when the determinant of A is not equal to 0, in that case we say the system of equations to be consistent, and in this case there is unique solution. Okay, so again we have to check the value of adjoint of A multiplied by B matrix. Okay, so if adjoint of A into B matrix is a null matrix, okay, then we say that this system of equations, okay, this system of equation is consistent, having unique non-trivial solution. Okay, this system of equation is consistent and having unique non-trivial solution. Okay, now if adjoint of A multiplied by B matrix is not equal to a null matrix, in that case, okay, this system of equations is consistent but having trivial solution. Okay, a trivial solution means x equal to y equal to z equal to 0. Okay, all the variables assume 0. Okay, so there is another case where determinant of A is equal to 0. Okay, so when determinant of A equals to 0, then we say that metric method fails. Okay, metric method fails. Okay, then we have to check the value of adjoint of A into B matrix. If it is equal to a null matrix, then we say that system of equation is consistent but it possesses infinite solution. Okay, so similarly if the adjoint of A into B matrix is a not equal to a null matrix, then in that case the system of equation will be inconsistent. Okay, and it possesses no solution. Okay, so that's it for this video. Thank you for watching this video.